Example to find out if there is a relationship between vegetarianism and income, you send out a questionnaire about diet to a sample of people from different income brackets. You statistically analyze the response to determine whether vegetarians generally have higher income. Naturalistic observation is basically a type of field research where you gather data about a behavior or phenomenon in a natural environment. This method often involves recording, counting, describing, and categorizing action and events. This observation can include both qualitative and quantitative elements. But to assess correlation, you collect the data that can be analyzed quantitatively. For example, frequencies, durations, scales, and amounts. This observation lets you easily generalize your results to real world context. And you can study experiences that aren't replicable. But data analysis can be time consuming and unpredictable, and researcher biases may skew the interpretation. Example to find out if there is a correlation between gender and class participation, you observe college seminars, note the frequency and duration of students' contributions, and categorize them based on gender. You statistically analyze the data to determine whether men are more likely to speak up in class than women. Secondary data. Instead of collecting original data, you can use this data which has already been collected for different purposes. That could be official records, poll, or previous studies. Using this data could be an inexpensive and fast because data collection is complete. However, data may be unreliable, incomplete, or not entirely relevant, and you have no control over the reliability or validity of the data collection procedure. Example, to find out if working hours are related to mental health, you use official national statistics and scientific studies for several different countries to combine data on average working hours and rates of mental illness. You statistically analyze the data to see if countries that work fewer hours have better mental health outcomes. Now, how to analyze this correlation data? After collecting data, you can statistically analyze the relationship between variables using correlation or regression analysis or both. You can also visualize the relationship between variables with a scatter plot. So different types are correlation coefficients and regression analysis are appropriate for your data based on the levels of measurements and distribution. First is correlation analysis. Using this analysis, you can summarize the relationship between variables into a correlation coefficient, a singular number that describes the strength and direction of the relationship between variables. So with this number, you'll quantify the degree of the relationship between variables. Correlation coefficients are usually found for two variables at a time, but you can use a multiple correlation coefficient for three or more variables. Regression analysis. With a regression analysis, you can predict how much a change in one variable will be associated with a change in the other variable. The result is a regression equation that describes the line on a graph of your variables. You can use these equations to predict the value of one variable based on the given value of the other variables. It's best to perform a regression analysis after testing for correlation between your variables. Correlation and causation. It is important to remember correlation does not imply causations. Just because you find a relation between two things does not mean you can conclude one of them causes the other for a few reasons. Directionality problem. If two variables are correlated, it could be because one of them is a cause and the other is an effect. But The correlation research design does not allow you to infer which is which on the side of caution. Researchers do not conclude causality from correlation studies. For example, you find a positive correlation between vitamin D levels and depression. People with low vitamin D are more likely to have depression, but you can't be certain about whether having low vitamin D level causes depression or whether having depression causes reduced intakes of vitamin D through lifestyle or appetite changes. Therefore, you can also conclude that there is a relationship between these two variables. Last is third variable problem. A confounding variable is a third variable that influences other variables to make them seem casually related, even though they are not. Instead, they are separate casuals linked between the confounder and each variable. So, in correlation research, there is a limited or no research control over extraneous variables. Even if you statistically control from some potential confounders, there may still be other hidden variables that disguise the relationship between two your study variables. Example, you find a strong positive relation between working hours and work related stress. People with low working hour report lower level of work related stress. However, this does not prove that lower working hours causes a reduction in stress. There are many other variables that may influence both the variables, such as average income, working condition, job security. You might statistically control for these variables, but you cannot say for certain that lower working hours reduce stress because other variables may complicate the relationship. Although a correlation study cannot demonstrate causation on its own, it can help you develop a causal hypothesis that's tested in control experiments.